A reservoir dam holds 8 kilometers squared of water in a lake behind it. The lake is 14 meters deep. What is the gauge pressure at the base of the dam in Pascals? And what is the absolute pressure at a point 1 meter down from the surface? Assume the pressure at the surface is 1 atmosphere. So for the first part of the question, we know that the gauge pressure is equal to the density of water times gravity times the depth of the lake. Substituting values in from the question, we know that the density of water is 1,000 kilograms per meter squared, or per meter cubed. Gravity is equal to 9.8 meters per second squared, and the depth of the lake is 14 meters. The product of these three is equal to 137,200 Pascals, or if you wanted to write it in scientific notation, 1.37 times 10 to the 5th Pascals. So this is the gauge pressure at the base of the dam. The second part of the question asks for the absolute pressure at a point 1 meter below the surface. So we know that the absolute pressure is equal to the atmospheric pressure plus the gauge pressure. So they gave us in the question that the atmospheric pressure is 1 atmosphere, and 1 atmosphere is equal to 101,325 Pascals. So I'm going to substitute this into this equation. Atmospheric pressure is 101,325 plus the gauge pressure, which we need to find because it says 1 meter below the surface. So gauge pressure would equal the density of water times gravity times the height, which will be 1 in this case. Density is 1,000 times 9.8 times 1. So we get the gauge pressure to equal 9,800. And the sum of these two is 111,125 Pascals, or in scientific notation 1.11 times 10 to the 5th Pascals is what the absolute pressure is at a point 1 meter below the surface of the lake.